control room building with controls for the bladder dam that includes pumps, electrical systems and controls. And so the reason for this meeting is that we wanted to incorporate or have our electrical staff and control staff be able to interact with our operations staff and also our project team to better understand the scope that we have requested from them, and to make sure that we're able to give them a good summary of what it is that we want to do for as far as electrical and controls goes for this project. One starting point that I think we can start with is earlier on this year, a little bit towards the end of last year, we met with the operations and in the field, and we kind of put together a list of items that they operations staff was requesting of us. And a lot of them had to do with things that relate to electrical and controls. So if everyone is okay with that plan, I think unless Ben and Zari, there are some more concerning issues or important issues that you want to get to right away, we can either do this now or we can put it off to a little bit later in the meeting. But that's what I could think of as a good place for us to start if there's nothing ideas that you had to talk about beforehand.
Okay, actually, for my unit, the ENC support for this project, we have a document. Let me show you that one.
Okay.
Okay, this is something Johan and me to put together about what activity we should support for this project. And I have some update yesterday, including something for the fish ladders. So basically, if you look at the schedule, we have some change. It looks a little bit which would be not like an original schedule. Will be pushed out a little bit, and then we want to, most of the control portion I can handle, including the control panel. I even asked for the panel shop to give me a quote, so that one is no problem on that one. But I still need some commitment from the SCADA team. That's why I invited James to attend this meeting, but he cannot make it because the program, the software need to support by the SCADA people, means James Ball and his team. And so far, I don't get a very confirmed on that one yet, but based on the schedule, if the schedule not too urgent looks, they can support it. That's all I can update to the project for the current status. For the electrical, Jerry and Karen will be support. Quite a lot design required to bring the drawing. And I also list something over here. And this is typically only for the rubber dam. But for the fish ladder, I don't know. Today, I think probably we need to have more discussion on how we want to handle the fish ladder. Because here I also have a picture on that one. Maybe people have more understand what you're looking for. Let me open that one.
From my point of view, this is Jerry. From my point of view, I think we should have more control from actually people on the ground there, just because of breeze and stuff, depending upon what kind of storms we're getting in, because there are a lot of tributaries, not only Anderson, but Fisher Creek, and a lot of the east side of the valley that actually feed into this that can bring debris down. So before we actually make adjustments to these fish ladders, raise or lower, it would probably be good to have staff on site rather than actually have a remote control system in here. But that's just my outlook on it, just from experience.
Yeah, I understand it. But how to get a solution to make that remote control function available? I don't know how much the electrical people can give us on the solution at this moment, but definitely we need to have some more understand at the side to see how we can put the electrical device, actuator, and so on to manipulate the removable gate, removable plate. I think that today probably we cannot have a solution right away, but I need to electrical people and the mechanical people give me some more idea what can be done. For the control, I don't think this won't be any PLC control, just manual, some panel, access the panel and some switches, some indication, and I can have some support on that if required. But basically, we need some idea how we can achieve that purpose. So here you can see there's some red gearbox. I call this a gearbox. As far as I understand now, the gearbox is operated by some temporary mounted actuator, right? I don't know what the detail.
Yeah.
Yeah.
Go ahead, Jason.
Oh no, it's just it's a Milwaukee power drill basically. It's just a square nut that attaches to those gearboxes, square shaft, and just rotates clockwise, counterclockwise, up and down when we plug it in and operate it.
Yeah, if only for this 3-1, probably still not too difficult, because we can have mount some maybe submersible pump, submersible motor, and have some wire to some remote area to manipulate it. But something below that one, I would say more difficult to do it. Yeah.
Well, I don't see there being difficulty below these first three, and we might actually need to install a fourth one, because the ones below that would actually be pulled up from the base of the concrete sill or the fish ladder, because it's the first three that control it, but we need some type of way of lifting the lower board, or not boards, but it would be a steel plate of some sort. So there'll actually be, instead of the 6 operators you're seeing here, there would be 12. One to raise the upper V-notch weir, and then one to lift the lower panel below the V-notch weir. That way we can get water to flow underneath the V-notch and the lower weir, or the lower plate.
Yeah. Yeah.
Have you been out to the site yet? Have you physically been out there yet?
No, I just look at the pictures.
Okay.
All right. So from 5, so if we were doing an additional one, instead of just these 3, and did 4, and everything below that would be basically lifting the panels up from the base of the concrete sill up off the ground to allow water to flow through for fish passage.
I think Jose, we're planning to do a total of 8 now, right? I believe there's 8. Yeah.
Yeah, I think 8 would be better. I mean, we've done less than that, but I think we'd be better off doing 8. All depending upon what the sill elevation is going to be for the new rubber dam, and as the rubber dam is deflated, what kind of elevation we'll have there too. Exactly.
Sorry, Jerry. The idea was Stillwater is looking at the fish passage through this thing. Actually recommended we add, because we were going to add 4 below these 3, 4 adjustables. They actually asked for a 5th, just because they thought it would give us greater range of flow, greater range of operation. So there'd be a total of 8 adjustable ladders, or 8 adjustable weirs. Sorry.
All right, which is fine as long as the water elevation with the dam deflated is giving us, 8 inches of water depth at the upper end?
About a foot.
About a foot? Okay.
About a foot. The delta between the floor of the ladder and the top of the deflated bladder dam should be about a foot.
Okay, all right.
So it should be okay.
Yeah, sounds like it.
Theoretically.
I'm Johan. For the Stillwater, their report say that all 8 of them should be double adjustable well. So meaning, say by the calculation for each one got 2 control altogether, multiplied by 8 altogether 16 control. At least this from Stillwater's report recommendation. They were saying all of the 8 wheels will be double adjustable wheel.
Yeah, so Ben, each panel has at least 2 of those little worm gear and adjustable things that need to be powered, and so I think we're looking into getting a spec sheet on one of these sort of worm gears, or one of these gears that are able to move them up and down. I mean, the goal is to be able to have that powered up, and then some kind of control panel that's up in a safe location, up away from sort of where the water surface can get onto this sort of walking surface, because it's a safety issue for our operations folks. So if we could put the control panel up at a higher location that can be locally controlled, that's the end goal here.
Yeah. I know the required function is quite obviously, but how to achieve. So whenever you need to move something, you need to have some so-called actuator. I'm thinking the actuator could be hydraulic type, because as far as I know, there are some valve in the dam. They are is submersible in the bottom of the reservoir. Definitely, they have no way to have an electrical to do any function on that, and they use the hydraulic, and then hydraulic will be more related to the mechanical design. So probably we need some mechanical engineer to involve and give some solution, especially for the gate in the lower portion, because most of it is a lot more water over there, not like the top one, the top 3 one. So I would say this will be a lot of design required to make that function we wanted. Yeah, I would say probably hydraulic will be a solution. Yeah, just like we have the fish screen. The fish screen, we have the swapper around the screen. It's hydraulic. It's hydraulic to as a driver to make the load rotated. So same thing here, to lift the plate up and down. Probably need some hydraulic mechanism. Yeah.
Well, we still need to look at it first. We need to look at the spec sheet first to see what it needs. I mean, whether it's hydraulic or electrical, we're not really sure. But
and we want to look at the report for what the real change on the gate, on the plate.
Are the agencies going to have a problem with hydraulic?
They don't say anything. They don't have mentioned anything on that yet.
I think we'll generally be okay. I think Jerry just thinking out loud here, but this is one of the facilities that's covered under the dam maintenance plan.
Mm-hmm.
it does keep the hydraulic, having hydraulic actuators at other places. So I think we might be okay here.
Yeah.
Okay, I'm just asking because of how they feel about certain things.
Mm-hmm.
Maybe how they feel about everything.
Well, that's true. We definitely agree on that stuff.
Mm-hmm.
Is it just a concern of spilling something hydraulically into the water? Yeah.
Yeah. That's the concern. Every time we do something in one of the reservoirs that has hydraulic controls, it's a giant concern for them. But it's okay. It's something we can work through.
Mm-hmm.
Okay. So then the preference would be electrical. I guess it's gonna right?
Actually, hydraulic cannot use only hydraulic. You also need some electrical to support it.
Sure.
Yeah.
So,
Oh, okay.
Yeah.
Yeah, but what I'm concerned about is hydraulic lines running down there underneath the water surface and debris coming down, getting past a log boom of some sorts and catching on one of those hydraulic lines. So it would probably need to be armored, metal casing or something like that to keep the line from getting damaged.
Yeah. Mm-hmm. Yeah, they have some different tubing. Yeah. Mm-hmm.
And then the new types of oils that are biodegradable and stuff
yeah,
like
with
that.
special oil. Yeah, special oil for that purpose. Yeah.
now, would those lines would just come into the top of the controls, right? We wouldn't necessarily have them underwater, would we? It would just be for the event of a high flow that overtops the whole facility.
Yeah, but the rams for the lower portion of the first 3 or 4
Would have to reach in. I got you.
have to be down into that area somewhere.
Yeah, I got you. I was only thinking about the lines.
Yeah, it's the rams too.
Right.
I'm not an engineer.
Yeah. Another way maybe have some something like a linkage for all these plate and live up all together. I just was thinking, could be so many different way to make it to design. For example, you have a beam, you have some linkage all this together and leave it up all together. If possible, if have a good mechanical design.
Oh, and that's why you think the mechanical might be helpful.
Mm-hmm. Yeah, seeing what idea they have.
Yeah. Yeah.
So
Right.
the thing about operations, and I hate when I do this when Jerry and Jason are on the phone because I don't do this; they do it. But these 3 that are here, these have to be able to be independently adjusted so we get the right flow through the weirs down below.
Okay.
I think in the case of the new ones that we want to install, the ones, the additional 5 downstream of these 3 we're looking at,
Mm-hmm.
those 5 would only be lifted
Okay.
in the event that we deflate the dam.
Okay.
So I think bringing all those up at the same time would be fine. The upper 3 would have to maintain their individual adjustment.
Okay. Individual. Okay.
That makes sense?
3 or 4.
Mhm.
It might be better off to put an additional one that lifts off the bottom of the chute there. But yeah, the ones downstream of that, they basically just need to be lifted off the bottom to allow fish passage.
Right.
The first 3 right now are just there for depth through the V-notch and elevation of the actual pond on the upstream one.
Right.
Yeah.
Jason, jump in here.
Yeah.
You guys, this is Kelvin. What do those gears spin? Sorry, I'm not familiar with it. Are these just walls that go up and down that
It's
control
just
the water flow?
Yeah, it's a work gear. It lifts up a panel. I can actually. Do you want to see an as-built?
Yeah, that'd be
I
great.
say Ben, I sent you a lot of pictures. That's what I was about to look at. I have pictures of the panels with no water in it. It's all dry.
Yeah,
Stuff. You can kind of
yeah.
see what it's lifting.
Mm-hmm.
But yeah, basically those shafts are threaded. I think that was Calvin.
Yeah.
And yeah, basically it just threads through it. That's what that gear shaft box on top is, turning it so it pulls the threaded gear shaft
And
through
lift
the
the entire
rod
rod
up there. Lifts it up. Yeah, exactly.
Okay. And right now these are, you said, with a portable drill. Just
Yeah,
screw onto it
Milwaukee
and then.
just power.
Yeah.
Exactly.
Okay.
Yeah.
A
So
very
right
big
now it's
portable drill.
oh,
Yeah.
what, Jerry?
I said a very big portable drill.
Yeah.
Yes. Very heavy. Takes time consuming.
I have
Emergency. It's
some.
not that feasible.
No, I think it does like 500 RPMs.
Oh wow. Okay.
Gets a little hot after a while if you're doing all three of them right away.
And it takes time. You know, I was out there when Ernest was out there for our survey, and it takes time to get those to be fully open and fully closed, because it's, like I said, how many times it spins, it takes a long time to get that big old shaft up and down. So it does take some time.
Well, I think the ratio is either 8-1 or 12-1 on those drives. I think they're 8-1 if I remember correctly, but I could be wrong.
Yeah, this is another picture showing on the other angle of the platform. Yeah, now they just manipulate all these three with some electrical drill. Yeah. So when the water level get higher, will be up to this platform, right? But this gearbox still above the water.
Yes, yeah. If we have the dam down, I mean, you're talking. You need a lot of water to get that high with the dam down, radial gates open, or whatever we're doing. It's probably not going to happen unless Anderson fails.
Mm-hmm.
That you get water that high.
I don't know. We got pretty close in 2017, even with the dam out.
And how about this platform on the top? Is how to access to that? It's going. If you come down here, you need to go up over here and then go down, right?
Yes.
It's the way to access to this one, yeah. So if you have some, yeah.
That's why I was mentioning at the top of that platform. There's like a little, area there. That's where to put the controls, I would think. So all the controls are up on top. So we don't. If that bottom part is flooded, the bottom platform, we don't got to walk in the water down there.
Yeah. Yeah, for this three one, I think it would be much easier to do it if we have a individual motor and then have some platform on the top.
Yeah. How accessible is this dam in terms of like to the public? Would we have to put this in a blockhouse, or can we have a controller out there and not necessarily worry too much about it?
I would say at least a security box of some sort.
Got it.
Yeah, the current what's it called? Radio gate controls are in a metal box, and then it just has a metal like latching cover to cover the locking mechanism. And we haven't had anybody damage that.
Okay.
It's currently gated off right now, and we're planning to install new security gates and some security equipment out there too, as part of the overall project.
The only damage I've seen out there was somebody stole all the electrical cables from basically the dam all the way down to the street.
Yeah.
Your copper people.
Yeah.
That's a pretty penny right there.
Yeah, it only took about 2 months to fix.
All right, so probably we need to have a more description on based on the function we prefer to have, and then go to some design work and see how we can implement it.
So, sorry, this is Kelvin again. So I'm seeing 3 of the weirs right now, and the plan is to have another 5 in line with those? Or, I mean, I can't orientate myself with the picture that Ben had showed first where we're looking up. But it looked like the ladder was a lot longer than that. Am I missing something here?
Yeah, you're just looking at the upstream part of it right here. These are the current adjustable weirs there's just 3 of them. But to the left is downstream.
Mm-hmm.
The other picture we were kind of looking.
Oh, got it. We're looking left to right.
Upstream now.
Mm-hmm.
So then
Okay.
we're gonna be replacing those 3 existing weirs with double adjustable weirs, and each one's gonna have 2 of those, gears per panel. So if there's a double adjustable panel, it's gonna actually have 4 gears, 4 of those gears, and then we're gonna add 5 more, adjustable new rear panels as part of the project.
Can you see my screen?
Yeah.
Thanks, Ryan.
So I know that's helpful. That's looking up. And you asked earlier about that walkway up above. So you can see that walkway coming in from the right of the photo. Sorry about the trees kind of blocking it, but
Yeah.
Yeah, and there's an embankment off to the right that you can't see behind the tree, and there's a gravel access road that comes in through Olympia County Park to access this whole site over here, and that's where our electrical comes in from the PG&E meter as well.
Mm-hmm. Kind of in that back. Okay.
Yeah, it's off on the right hand side, so we're we're already working with PG&E for a new service agreement.
Correct.
So on the left side of that catwalk, operationally wise, it would be better to have the actual controls there where you could actually visually see what you're doing with the weirs and stuff.
Mm-hmm.
Kind of like Jason said.
Okay.
Yeah, I know submersible pumps were kind of discussed in the beginning of the meeting. I would highly recommend against those, especially since this is in unfiltered or untreated water. If these things don't get spun very often, submersible pumps will just get eaten up or clogged up relatively quickly. I'm not actually sure how a submersible motor would apply to that application either, but I think a limit torque actuator at the top, on top of the worm gear, that would be ideal for that, and then you can run the controls back to a little control panel that's lockable, similar to all the other sites.
Mm-hmm.
Oh, there we go.
Oh, there we go. All right, you guys see my screen?
Yeah.
Yeah.
Okay. Let me open some of these. So yeah, this is what the bottom looks like. Kind of the adjustable and the plates and stuff like that. The board's kind of what it looks like. Let's see. Waiting for it to open.
And it's only that gray piece that goes up, right? It looks like the wood at the bottom doesn't come up with it.
Correct. Yeah. So there's the wood slots. If you can see the wood slots, and then there's the metal V-notch that goes on top of it. So the boards go at the bottom, don't move, and then the V-notch sits on top of all that doesn't move. And this is the adjustable ones, the 3. So the steel plate, there's a little gap in between there, so they don't touch each other, they don't sit on top of each other, they just kind of pass each other, left and right. So those boards stay at the bottom. So this is what kind of we're talking about. These might have to be lifted too, so the panel will move, and then these boards need to be lifted too, so we can get to the bottom seal down here of the concrete, so we can pass all the low flow hitting the bottom of the concrete.
I think what we're thinking is double steel panels instead of the wood, Jason.
The wood. Yeah, get rid of
As long as they don't have much leakage between them.
Sorry, Jerry, what?
Said as long as they don't have much leakage between them, we need something that actually seals up pretty good. Because we've run into this in the past where we've had water actually pass under the steel adjustable V-notch or around it, and we haven't been able to pass water through the V-notch.
Gotcha. Okay.
Yeah, so this is what we did after the drought. We rebuilt everything. We put this hyperlong, some plastic and boards, kind of to water seal it, kind of tighten it up. This actually worked pretty good now. Just waiting for it to open. But yeah, if we can, I think Jerry said, make it sure it's watertight. We're not getting all the water leaking through it, because then we'll never fill these panels up.
Yeah, it
And
doesn't
they can
have
still
to be
through the V-notch
perfectly watertight. It just has to be,
Yeah.
you know, less than 1 CFS type thing.
Okay.
So yeah, this is the view, kind of what the rest of those panels look like. This is kind of what I was also thinking, Ryan. We kind of talked about, I don't know if in the future, or maybe this project, we make these panels, the rest of them that aren't really, going to move. But if we ever do need to service them, put them like Alamitos, the wood in a metal frame, and then we can just lift it up all out at once, instead of right now we can't service these panels at all without draining this out, pumping it out, getting in here, replacing the boards, cutting stuff out.
Right. Yeah, Jason, Jason or Jerry, do you guys have a picture of an example of those Alamitos boards? We were talking about it in the team meeting the other day, and I was trying to explain it, but I can't find a picture of them, like when they're out.
Yeah, let me see here.
The steel. I mean, if you can just send it over to the team,
Oh, okay.
that'd be really useful.
One of the
yeah.
biggest problems with this current design at Coyote Perk is the fact that we have to bring an emergency crews to actually have us attach the cables and stuff like that. And if the water level is kind of high and we have leakage, they have to wear chest waders, and it's about 5 feet deep in each one of those chambers. So it is unsafe.
This is Johan. I have a question regarding the 5 additional one just now Jason was talking about. So you do have a room to lift the panel?
Yeah, we can come in through the north side.
Okay.
There's a concrete pad we can bring a crane in through
Okay.
to lift these out, like what Jason's showing right now. The problem with is the width. I mean, with the one at Alamitos, it's 15 feet wide or so. I think that's 4, 8, 12 feet.
Okay.
Problem we're going to have, Jerry, is when we redo this facility and lower the foundation, you're going to lose that apron.
That is true.
So we'd have to bring in a truck. I don't know how we would do it, actually. We'd have to think about that.
Well, that's something that should be brought up, because we need access to it. Even though if it is a inflatable dam, we need some kind of access to it.
There'll still be a grouted rock slope protection on the downstream side. You just won't have the same 15-foot wide concrete apron that you have now.
All right.
So some we'll have to talk about, I'm sure, going forward as we look at the design.
But the thing about it is, we do the first 8 gates
Yeah.
movable, then we shouldn't need to go in there except when we're replacing things
Right.
downstream.
Yeah. We wouldn't be going in we'd be going in a dry condition, not a wet condition.
Exactly.
Yeah.
Dry condition.
So yeah, we'd only.
It's not a flood condition. Summer,
Right, it would just be
summer
for
release.
servicing summer. Yeah.
With the dam, it deflated.
Right.
We will talk about this because currently actually only granted.
Mm-hmm.
Okay, we can talk about this.
Yeah, we can figure it out. We can work out the details.
Sure.
But the preference would be to have some kind of a maybe 15-foot wide access from what did you say, the north side, to be able to access the fish ladder in case you need to remove things. Because I don't know, like the grouted riprap may get cracked with that heavy equipment, I'm guessing.
We bring the crane down there right now. It's thick concrete. Yeah, it should be all right. It's just like Jared said. When the bladder dam deflates, what's going to be the footprint laying on the floor? Will we have enough room so we're not going to go into the creek with the excavator or the crane?
Yeah. Okay.
Okay. So 15 feet is.
But yeah, right now.
15 feet is wide.
Because right now
enough,
that's.
right?
I guess we can take a look at our equipment District has, the crane and all that stuff. I think Vinny gave you guys some of the specs on the crane we used, for the radio gates when we put the panel in and all that with that building that one time. So I would imagine probably the same size crane, because we do have to pull that vacuum. There's a fish counter vacuum system, and they do pull it out of, on the other side of the creek over there, and they load up and pull everything out right now.
Okay. Ryan, do you think the fisheries would have an issue if we put in a new concrete, sort of apron in there, just outside the slab of the bladder dam?
I don't know. We'd probably look at I don't know. This is where we start to get this fish passage and the slope and all that thing. That's where it starts to get a little goofy.
Yeah.
But I think we can probably come up with something that'll work. None of this is unsolvable.
Yeah.
We can come up with something.
Yeah.
And it may be just, there might be some alterations to how we put that rock slope protection back in to maybe meet a fisheries goal on one side to balance that out with a maintenance need on the other. Yeah. I'm brainstorming over here as I'm listening to all this and about ready to take a drive out there so I can think about it. But I think we can work it out.
Okay. We just slip it in there and hopefully they don't notice.
I don't honestly think even if we sloped it in, we just put in two clear, like a little ranch road that's just got two tracks for the tires to drive on, and then put some rock over the top. I mean, I'm just, like I said, I'm just brainstorming.
Sure, yeah, that's a good idea.
Okay.
I mean, the vacuum thing's the only thing that hangs me up, because I was actually thinking, why don't we just put a crane down on the bottom of that peninsula in the turn? Doesn't have to be much to lift those little panels. They're not very big. I don't know. Sorry, like I said, I'm totally brainstorming, so don't listen to me.
Yeah. All right. Well, yeah. So then the bladder dam, I just want to throw it out there with Jason and Jerry. We were thinking to have local control, but also it's an option remote control as well, like remote control from Rinconada water treatment plant or something like that. Is what we were currently thinking, and I just wanted to check with you guys if that makes sense.
As in a SCADA control that a water operator could. Oh, sorry, a water operator could inflate and deflate the dam.
Yeah.
Do we have any SCADA controls over there at the moment? I think we'd have to.
No.
Then.
Yeah.
There's nothing there.
That might be pretty intensive. Or
to
get either a radio or a microwave signal, and then we need a backup signal as well.
Yeah, that would be
really
in the
like
design.
On one form of communication.
Yeah.
I mean, Ben, is Kirk Dam set up? I mean, I know the SCADA issue. I'm still having to figure all that out with the alarms and stuff. Nothing is set up on SCADA for Kirk. Not even the intrusion alarm to the door. But they can't control the bladder dam, right?
Yeah.
Kirk?
It's in progress. The SCADA team actually now, the equipment is almost everything is ready for that purpose, but the software is not there yet. And I keep asking the SCADA team to look for that. And so far, actually, it's the Tom. Tom, we work with the Brian team to see how much he want to look at, how much information he need to to monitor, and then he put into the software. It's in progress.
I got a list of all
Yeah.
the tags as well, and
Right.
I got some comments on that.
That's in progress. Yeah, it takes time.
Yeah, but haven't we had a lot of problems with the level indicators and different things
Yes.
out there that's caused the deflation of the dams? So
That's what, I was going to mention. I think, and that's where I want to talk to you, Jerry. I think it's probably not a great idea just to have an operator from Reconada just be able to push a button and deflate it if they're not seeing downstream conditions, right downstream of the dam or around it or upstream without physically being there. What do you think?
no, I don't think it's a good idea at all, and that's why I mentioned about debris and stuff in the fish ladder.
Right.
Is just for the fact that systems can fail, and we've seen it before over the years. So I think an actual eye on the ground is better than some technology that's out there. I know technology's the new thing, but
as we know, Jerry, it failed and it deflated Kirk Dam like 3 times on us, full of water.
Yeah, I think it was more than that, but
yeah. So I don't know. It's just I think we need to weigh out the pros and cons on putting this on SCADA and operating it. I think definitely we should have some kind of stuff on SCADA, like the blower motor, oil stuff, overheating, stuff like that. But
intrusion alarms. But
exactly.
I mean, with the issues we've got on Guadalupe River, as far as flooding and stuff during a high flow event, if that dam was to actually deflate from something that a guy sitting in a console did and caused flooding in downtown San Jose, that could be a liability for the district. That's why I feel that we would have to actually tie in stream flow stations, rain gauges, and all that for a deflation process in the event of a big storm.
Okay.
Now, maybe tying it in with the new outlet structure from Anderson to Coyote Perk might be something would be advisable for the maximum flow over top of the dam. With the valve position at Anderson, I could see something like that, but an actual person just doesn't know what's going on out there, especially with Fisher Creek and all the tributaries that dump in below Anderson. That's something that needs to be done by a person on site, and that's just my personal feeling, guys.
Yeah.
Same thing. It's just, there could be someone just downstream. Let's just say it's not a high flow event, and something, someone hits the deflate button. Well, now you just drowned somebody or killed somebody, by someone in an office, pushing a button by accident. It's like, at least we're checking stuff downstream, making sure no one's in the way, fishermen on the dam or whatever, you know what I mean? There's a lot of variables out there that we check before we push a button, deflate stuff.
Okay.
Just something to think about. I think we should have a kind of pros and cons if we really want to go that route. It'll probably save everybody a lot of time if we don't get SCADA stuff and out there and involved. Cost and time and money and all that.
Yeah. Okay, good to know.
So actually,
Use SCADA for monitoring and stuff, but the actual physical deflation or raising the fish ladder gates and stuff like that, especially during a big storm, probably need to have somebody out there to take a look and see what kind of debris load we've got and stuff like that.
Yeah, because raising those panels, the fish ladder panels, it's we gotta physically look at them, adjust them properly, just so there's the even jump between each step. So, having someone just put 10%, raise it up, that isn't going to mean anything. It might not be passable for fish, especially if let's just hope Fish and Wildlife isn't out there when this is being adjusted, remotely.
And with the rubber dam at Kirk, when you deflate it, it's not a nice, even, steady flow that comes out. Basically, it's deflating, and it's a surge of water. So you imagine the water standing behind Coyote Perk surging out in 15 minutes or 30 minutes, however long you decide to do a deflation on it. It can be quite a bit of amount of water, and if you've got a storm, say on the northeast side of the valley in Coyote Creek, you could wind up with some flooding. So those are the type of things we need to look at, and if we're going to actually tie this into a SCADA system that they can actually adjust on the fly, we need to know what's going on downstream before we actually make those adjustments.
Do we see this? Yeah, because the curtain we only have inflated or deflated. We don't have any adjustment for the height of the dam. Do we think this then need to be adjustable high, or just inflate or deflate? That would be a big difference.
Yeah, but still, when we go out there and deflate it on site, just trying to deflate that dam in a controllable manner is not very easy, because normally what happens is the center of the dam drops, and then you get this surge of water going downstream. And yeah, it may not be an automatic surge like the dam failing or something like that, but it's still a good amount of water. If the system downstream is dry or just basically low flow type of, water flow downstream of the dam, it's not a big deal because it can suck it up, because it has to fill up all the pools and the side of the banks and all that. But I mean, when you're talking that amount of water, and I mean, it's only less than 400 acre feet below Coyote Perk, that's still quite a bit of flow when you're actually having a big rainstorm, and you've got all the tributaries flowing water into Coyote Creek downstream of Coyote Perk.
Yeah, the operation is some different than the curve.
So Ben, it's 1.7 feet above, or 1.4 feet above Kirk Dam before it automatically deflates.
Yeah. Actually, because that's for the protection of the dam, but now is safety will be more important than protect the dam. So I am thinking whether we need to automatically deflate it or not in this case. Yeah, I think we need to talk to Johan on how this dam should be. Yeah.
If we had an elevation gauge on Coyote Perk, we could actually get somebody out there in 30 minutes to an hour to take a look at it. But 30 minutes to an hour is a lot of time.
Yeah.
If we've got a lot of storm activity upstream of the dam.
Yeah. Yeah, we need to, yeah.
The meter will not be a problem.
Exactly.
Yeah. Where to put?
The radio gate is not big enough, huh? The radio gate. Now, the radio gate is only local operated, right?
Correct.
Yeah.
Currently, yeah. I mean, you could probably set those up to be a little bit more automatic. Because they're kind of restricted to a certain amount of flow and a certain amount of elevation.
Yeah, maybe that can be some automated. Yeah. Before deflated the whole dam.
Yeah. And you still probably need to get somebody out there to verify debris load and that type of thing. We have to bring maintenance in, especially if it's a big storm and we've had a fire or anything anything like that upstream, below the base of Anderson and Coyote Perk. And what we saw in 2017 was the amount of trees that were dislodged during that storm of 72 to 7,400 CFS over the spillway. And that's a lot of dead debris that did not make it to Coyote Perk yet. But we did get a good portion of that. Oh, quit yawning, Carl.
Oh, sorry. Should have put more video off there. This is really interesting stuff, in spite of my yawning. Okay, so I'm hearing local control only. This makes it easier on us, right?
Well, I'm not saying local control on everything, but at least give us some idea of what's going out in the system, and have maybe the Rankin ought to call us and let us know, hey, this is what we got out there. Because kind of like what we have set up with Ken Stump's unit, with alarm settings and stuff like that, where we can make a decision from home, but your best bet is to actually go out on the field and verify that we don't have debris pile up or anything like that.
Okay.
You agree, Jason?
Yeah, absolutely.
I
I'm kind of
have
on board.
always.
Sorry.
Go ahead, though.
I'm kind of on board with having some alarms and stuff like that, but I am not it sounds like the remote control of all this doesn't seem like a good idea. But intrusion alarms and level alarms, I think that would be nice to at least send back somewhere. Maybe not SCADA per se, but maybe something that's accessible to district employees, maybe through like a cell modem or something. Just because I don't know how comfortable water or the raw water operators are going to be with monitoring levels of reservoirs or like dams. Or I'm not even sure if that's something that they typically do either.
So far, do we have any security monitoring on this line? I know they have project so-called water protection. I don't know this is including that project or not. Like some video or some intrusion alarm. We need to look at it. If we don't have it, if we require, then put into this project.
So on a lot of our reservoirs, we actually set an alarm setting for elevations, maybe a foot or 2 feet, depending upon DSOD restrictions and other factors on these reservoirs to give us a heads up to get our asses out of bed, and actually take a look at the alert data and stuff like that, figure out what's coming into the reservoirs before we actually make an opening of the outlet or anything like that.
Okay.
So this is the type of debris load that we saw at the radial gates.
Yeah, and these radio gates, I think, are almost all the way open as well.
Yeah.
I mean, you can walk across it. I think it took maintenance about 4 days of pulling debris out of there just to see the bottom of it. So this was during 2017. Some of the aftermath.
And this is only the upstream section of it. I mean, the Dragon's Teeth below the radial gates were plugged up too.
Yeah, you can see it went all the way back to the entrance almost of the fish ladder panel. That's how far back the debris blocked up.
Wow.
And this is with the steel panel dam out.
Wow.
So this is kind of what we're getting at is we want to make sure that Rinconada doesn't just open something up and this is sitting right behind it all, and they don't let no water out, or this debris rips the dam apart, right? It punctures a hole in the rubber, or jams the radio gate or something, and they're doing this at 1 o'clock in the morning. Well, maintenance crew don't start and get out there till 8 o'clock in the morning, so we're gonna have a big problem for a while out there.
Well, more of my concern is actually a debris load larger than this being behind the inflatable dam and going downstream and getting caught on a bridge abutment or a setter section or something like that and causing flooding downstream. A pier nose or something like that getting clogged up with a bunch of debris.
Yeah, just upstream at Metcalf, that's what happened.
Well, we got another meeting at 2:30, right, Jose?
I think we're all on this meeting.
I think so too.
That's the same one, huh?
Drought conditions.
So,
So I have one quick question before if we're going to end this meeting soon. I know when electrical first started this project, it was just to replace the current blower that was at the Kirk Dam. It sounds like that's since expanded a little bit. Is that my understanding, or has it always been to integrate some new controls and some new weir gates and stuff like that?
so Lava Dam probably we pretty much duplicate the Kirk Dam, but the fish passage, the fish later will be some new item in this project, just like we discussed.
Yeah, so to reiterate what Ben said, I guess it's always been, we've always kind of known that we needed controls and such for the bladder dam. But as the project has progressed, the fish ladder adjustable weirs is kind of like the new component that we're going to add as far as needing additional electrical power out there to be able to provide power to the adjustable weirs that we're going to be installing. But yeah, it's just like Ben said, we want to duplicate as much as we can from the Kirk Dam, and in that project, they have controls set up for the bladder dam. Without those, we can't control the bladder dam.
Yeah, I wish Jared or Harold would be on, but I would, and I mentioned this, Carl, kind of to you guys in the beginning of all this. Talk with them about what level sensors they have and all that, what they replaced. I think they're a lot better, more reliable, off the shelf they can replace if there is an issue, because they had to rebuild everything that was at Kirk as far as the level sensors and stuff, because they couldn't find where those were made and all that stuff and what those were. So just keep them in mind, just keep them in the loop with that.
Yeah.
Yeah, I think minor. I remember that. So we'll have to get in touch with Harold Legore to pick his brain on that.
Yeah, Jared too. He's the supervisor now over there, in charge of Harold.
What's his name?
Olson.
Okay.
Yeah, this project we use the so-called guide wave, radio guide wave level instrument, not the floating, not the one we already replaced with the new type of the level instrument. So far looks good, and this project will be used the same type, radio guide wave. Do we have a temperature sensor for this project? I think we should have temperature too, right? The curtain we have
Pretty sure
temperature. The curtain
Pretty
we.
sure it's gonna be asked.
Mm-hmm.
Gonna get asked, yeah.
Yeah.
We all the way.
That's what put it in.
So the fisheries folks?
Mm-hmm.
Yeah.
Yeah.
Yeah, curtain have temperature. I think this probably have temperature too.
They'll probably ask us right at
Mm-hmm.
final design.
Mm-hmm.
They're gonna ask us in the LSA that I currently have in the works, so
Mm-hmm.
Oh, okay.
it'll be it.
Just put it in, and then we won't tell them we have it in. And then when they request it, hey, we got it in.
What a
Mhm.
miracle.
Exactly.
Yeah, and,
So
and these
on
would
electrical,
be,
on
Used to be-
electrical, are we going to actually just move one gate at one time? Or do you want to do several at one time? Just thinking about load and stuff like that.
That might need a mechanical design to tell us what size actuator we would need. If we decide to use a limit torque, I can't imagine these being more than like a horsepower or two. I can't imagine that these metal, I forgot what they're called. The weirs? Are they called the weirs? Are those the weirs themselves?
Mm-hmm. Yeah, well.
I can't imagine that the weirs are that heavy, especially when you have a 8 or 12 to 1 gear at the top of it. I don't imagine that much horsepower is needed to actually move them.
Yeah, just keep in mind the water over the top of it, and hopefully there's not a log sitting on top of the weir as well.
Well, just the water pressure load on the lower panel, if we're going with the deflated dam and raising the lower panel at the same time, that pressure can put a lot of load on a system.
Good point.
All right, next meeting.
Really?
Yeah, I think we're 5 minutes late to the next one, everybody.
All right, I'm gonna beat you all there, and it's all gonna be your guys' fault. You'll be the latest.
Thank you, everybody. I appreciate it, Ben and Calvin and Zari. Everybody else, thank you.
Thanks, everybody.
Thank you.
Bye-bye.
Thank you.
Thank you, Ryan.
So Jose, we prepare the minutes of meeting, right? For our discussion.
Yes.
Okay, good. Thank you.
I guess Carl already logged off. Okay.
Mhm.
Okay.
All right. Thank you. I have another meeting. I have to leave.
Yeah.
Mhm.
Okay. Bye-bye.
Bye.